Ever feel like you can study for hours and still forget everything? What if learning could be a tool you actually control, not a guessing game? Most people learn by cramming facts. Anderson and Krathwohl flip that. There's a clear ladder from remembering to creating, and using it changes how fast you learn and how long it sticks. I'll walk you through the 6 steps with real, tiny experiments you can try right now, including a quick math trick and a game you can play with a friend, so you stop wasting time and start building knowledge that actually works. By the end, you'll see exactly what to do next time you want to learn anything, and you'll know why it works. Bloom's taxonomy started as a simple question: how do we move students from, "I heard this," to, "I can make something new with this"? In the 1950s, Benjamin Bloom and a team of educators mapped out a hierarchy of thinking skills. First you remember facts, then you understand them, next you apply them, then analyze, evaluate, and finally create. In 2001, Anderson and Krathwohl updated that ladder. They swapped some labels, turned nouns into active verbs, and made the model easier to use when designing lessons, studying, or just learning anything on your own. Think of the taxonomy like a toolbox for thinking. At the bottom is remembering, simple recall, dates, formulas, words. Above that, understanding means you can explain ideas in your own words. Applying is using knowledge in new situations, like solving a math problem you've never seen but using the same method. Analyzing breaks things into parts and shows how they relate. Evaluating lets you judge which idea or solution is better and why. At the top, creating is assembling parts into something original, a plan, a proof, a story. Why that matters. Most learning feels random because people skip steps. You cram facts remembering and expect to innovate creating. The taxonomy forces a map. If you want to master a subject, you choose the right tool for the job. Practice recall when you need speed and accuracy, explain concepts to move toward understanding, do small, real tasks to practice applying, outline and compare ideas to analyze, make criteria and test options to evaluate, then build something new to create. Each level has clear activities tied to it: flashcards for remembering, summaries for understanding, worked problems for applying, diagrams for analyzing, critiques for evaluating, and projects for creating. Anderson and Krathwohl's verbs matter because they make the steps active and measurable. Teachers use them to write learning goals students will be able to, and design assessments that actually test thinking, not just memory. Learners can use the same approach alone. Instead of asking, "Did I study?" ask, "Can I explain this to someone else?" Or, "Can I use this idea in a new problem?" That small shift turns passive study into practice that builds long-term skill. Practically, Bloom's helps in everyday life, preparing for a job interview, learning a hobby, or studying for exams. It gives a plan. Start by gathering facts, check you understand them, practice using them, break down complex bits, judge options, then create something that proves you truly know. That's why Bloom's, especially the Anderson and Krathwohl revision, remains one of the most powerful, simple guides for turning information into real, usable knowledge. Remembering is the starting point. It's raw facts and simple recall. Picture a student reciting multiplication tables or a gamer remembering button combos. Practical moves here are flashcards, quick quizzes, and mnemonic tricks. Example. Memorize the formula for area of a circle A equals pi r squared, by repeating it, writing it down, and testing yourself until it comes out automatically. Understanding means you can explain the fact in your own words and link it to other ideas. Imagine explaining that circle area formula to a younger sibling, why radius matters, not diameter, and how pi relates to a circle's roundness. Practical activities. Paraphrase concepts, draw simple diagrams, or tell a short story that uses the idea. Example. Show how increasing r makes area grow much faster by sketching circles with different radii. Applying is taking knowledge out of the textbook and using it. This is where you practice on real problems. For the circle formula, application would be solving real-world questions. What's the area of a circular garden with a 3 meters radius? Use practice problems, worked examples, and timed exercises. Games work well here. Give a friend measurements and see who calculates fastest. Analyzing breaks the idea into parts and inspects relationships. You ask, what assumptions are we making? What parts affect the result most? For circles, analyze how area changes if you double the radius versus doubling pi, which you can't really change. Create a table comparing radius, diameter, circumference, and area, draw cause-effect arrows. Activities. Compare methods, make flowcharts, or reverse engineer a solved problem to see each step's purpose. Evaluating is judging ideas, methods, or solutions using criteria. You weigh options and defend a choice. With circles, you might compare using radius-based versus diameter-based formulas for different problems, or decide whether approximating pi as 3.14 is good enough for a construction task. Practical tasks. Write short critiques, rank solutions, or test which method is safer or faster in real conditions. Creating sits at the top, assembling parts into something new. This is designing, inventing, or composing. For our circle example, creating could mean designing a circular planter system that uses specific area constraints and budget limits, or inventing a math puzzle that teaches area through gameplay. Activities, projects, experiments, building models, coding simulations, or composing explanations that teach others. Put together, these levels form a ladder you climb intentionally. Start by making facts automatic, then check you can explain them, practice applying them in low-stakes situations, dissect problems to understand why methods work, judge the best tools or approximations, and finally build something original that proves mastery. Use simple, concrete exercises at each level. Flashcards: remember, explain aloud, understand, practice problems, apply, compare, diagram, analyze, justify choices, evaluate, and projects: games, create. That sequence turns scattered study into a repeatable strategy, and it's easy to test. If you can create something useful with the idea, you've likely reached the top. Start by picturing a student trying to learn guitar chords but getting stuck on one song. That's a perfect way to map activities to thinking levels. For each level below, I'll give what to do, exactly how to practice it, and sample questions or prompts you can use right away. Remembering, quick storage and retrieval. What to do, build fast recall. How to practice, flashcards, spaced repetition apps, short timed drills, and simple fill-in-the-blank quizzes. Sample activities. Create 20 flashcards, run a 5-minute drill, use a spaced representative app for daily review. Questions: prompts. What's the formula term? List the steps. Name 3 examples. Understanding, translate and connect. What to do? Turn facts into your own words and link ideas. How to practice. Explain aloud to a pretend student, write 1-paragraph summaries, draw simple diagrams or analogies. Sample activities. Teach the idea to a friend in 2 minutes, make a 1-slide summary, sketch a concept map. Questions: prompts. How would you explain this to a kid? What's another way to say this? How does X relate to Y? Applying. Use knowledge in real settings. What to do? Apply rules and methods to solve problems. How to practice. Do worked problems, case studies, simulations, or low-stakes real tasks. Sample activities. Solve 5 new problems, set up a mini project, play a rule-based game. Questions: prompts. How would you use this to solve X? Which formula fits this problem? What steps would you take next? Analyzing. Break it apart and inspect relationships. What to do? Identify parts, assumptions, and patterns. How to practice. Compare methods, create flowcharts, reverse engineer solutions, or run controlled experiments. Sample activities. Make a pros and cons table, outline a proof, map cause and effect links. Questions: prompts. What assumptions are we making? What are the underlying parts? How does A influence B? Evaluating, judge, defend, and choose. What to do? Set criteria, test options, and argue for the best choice. How to practice. Critique solutions, score alternatives, run quick A/B tests, or write short justifications. Sample activities. Rank 3 methods and explain why, test 2 approximations and report results, write a 1-paragraph recommendation. Questions: prompts. Which option is better and why? What evidence supports this choice? When would this method fail? Creating. Build something new that proves mastery. What to do? Synthesize parts into an original product. How to practice. Design projects, invent problems, compose explanations, or prototype solutions. Sample activities. Build a mini project, write a tutorial that teaches the idea, design a game or experiment using the concept. Questions: prompts. What new product or example can you make? How would you combine methods to solve a complex problem? Can you create a problem that tests others? A simple daily routine ties this together. Spend 5 to 10 minutes on remembering flashcards, 10 to 15 on understanding, explain or summarize, 15 to 30 applying practice problems or projects, then rotate and analyzing, evaluating, or creating task across the week. Use concrete, measurable prompts above so you always know what success looks like. If you can make something new that uses the idea, you've reached the creating level. Imagine a teacher with a single 45-minute lesson on percentages, basic stuff, definitions, a couple of worked examples, then homework. It works, but students forget most of it by next week. Let's follow the same lesson and turn it into a Bloom sequence that actually builds skill. Start with remembering. 5 minutes of rapid recall. 2 quick flashcard rounds on key terms: percent, base, rate, and a 3-question pop quiz that asks for definitions and a simple conversion: 25% right pointing arrow decimal. This makes facts automatic so students aren't fumbling for terms later. Move to understanding. 7 minutes of simple translation. Ask students, in pairs, to explain what a percent is, in 1 sentence and draw a picture that matches. One pair shows, percent is slices of a pizza, another shows, percent is pieces of 100. Have each pair swap and give a 1-sentence summary back. That proves they can paraphrase and link the idea to something concrete. Next, applying. 10 minutes of live practice. Give 3 short real-world problems, calculating sale prices, tax on a snack, and a tip at a restaurant. Students work individually, then check answers with a partner. Use a timed element. 2 minutes per problem. This shifts knowledge into action and reveals who can use the formula under mild pressure. Now analyze. 8 minutes to dig into structure. Show 2 solutions. To the same problem, one correct, one with a subtle error, like mixing up base and rate. Ask groups to list the steps and spot the mistake, then explain why the wrong approach fails. Prompt. Which step changed the outcome? That teaches students to see assumptions and common pitfalls. Then evaluate. 5 minutes of judgment. Present 3 methods for solving a shopping discount problem: mental shortcut, formula, and percentage table. Students rate each on speed, accuracy, and ease for different contexts, e.g., quick estimate versus precise bill. They must pick the best method for buying a laptop and defend it in one sentence. This builds criteria-based decision skills. Finish with creating. Last 10 minutes is a challenge project. In small groups, students design a short poster or a 2-question quiz that teaches someone how to calculate a tip and check if they learned it. One group might craft a quick game where players spin a percentage and calculate the new price. Each group presents their product to another group for immediate testing. Wrap up as a 1-minute self-check. A single prompt: can you teach this to someone who's never seen percentages? If yes, they've likely reached creating. This sequence turns a forgettable lesson into deliberate steps. Lock facts, prove understanding, practice use, dissect errors, choose wisely, and make something new. That structure turns short classroom time into lasting skill. Start by imagining your morning routine as a tiny classroom. You want to learn a language phrase, master a work formula, or finally understand one tricky concept, but every time you try, it slips away. That's the problem. Scattered practice, random study, and zero plan. Bloom's sequence fixes that by turning any small task into a step-by-step climb from facts to creation. First, lock the basics. Spend 2 to 5 minutes on quick recall, flashcards, voice notes, or repeating aloud while you make coffee. This gives your brain the raw pieces it needs. Next, explain the thing in plain words. Talk to yourself or message a friend a 1-line summary. That moves you from knowing to understanding. Then use it. Take one real problem related to the skill and solve it now. Don't save it for later. If it's a phrase in another language, use it in a sentence to order coffee. If it's a spreadsheet formula, actually plug it into a real sheet. Applying forces the knowledge out of your head and into action. After that, break it down. Compare 2 ways to solve the problem, find where mistakes happen, and write down the small steps. This analyzing step shows why one method works and another fails. Next, judge the options. Pick the fastest, safest, or simplest method for your real-life situation and explain why in one sentence. Finally, make something new that proves you've learned it. Build a tiny cheat sheet, a 1-question quiz, or a 30-second voice memo teaching the concept. This creation step is the real test. If you can produce something useful, you've climbed the ladder. The challenge: most people stop after the first step, they memorize and quit. That's why knowledge fades. If you follow the full Bloom flow 3 times a week for 1 month on any skill, you'll notice real change, faster recall, clearer explanations, and the ability to use ideas when it matters. You've just learned a repeatable routine. Remember, explain, apply, analyze, evaluate, create, use it daily in tiny bursts. Ready to cut memorization time in half. Watch Memorize in half the time. 10 scientifically proven memory hacks.